Alright guys, here's a short video on multiplying polynomials. So let's start off with something like this. X plus 1 squared. And it would make a lot of sense, and it would be really nice if we could just write the answer as x squared plus 1 squared, right? It would be nice if we could distribute that 2 across both of those things. But let's see if that works. Let's go and use a technique here where we just try some real numbers and see what we get and see if our theory is valid here. So if this is true, then we could rewrite this as 10 squared plus 1 squared. 10 squared is 100, 1 squared is 1. That should give us 101. Now let's check this out. 10 plus 1 is really the same thing as 11. 11 squared is 11 times 11, which is 121. So we have a problem here. And that disproves our initial hypothesis. We are hoping that that 2 would distribute and hit both of those terms. So let's talk about why that doesn't work. Let's say we wanted to draw a box that is 11 by 11. Instead of writing 11 by 11, we're going to draw this a little differently. And we're going to say it is 10 and 1 and 10 and 1. It's still 11 by 11. We know the area is still going to be 121, but now I've just broken it up differently. So now this region is going to be our 10 squared. This region is our 1 squared. And going back to what we had, 10 plus 1 squared, we do get 10 squared. We do get 1 squared, but we also get these different regions. This region has an area of 10. This region has an area of 10. And so we have 2 10s. So we get 100 plus 20 plus 1. So let's do that same thing now with x plus 1. Draw our box. And we have x and we have 1, we have x and we have 1. X times x is x squared, we have 1 squared. So you do have x squared, you do have 1 squared, but you also have this region from here to here is x, same as that. So this region is x times 1, the area is going to be x. From here to here, this is the same as this. This is also x. So the area of this region is x times 1, it's x. So you have, as your final answer, as an area, you have x squared, which is this guy. You have 1 squared, which is this guy. But you have an x and another x, and that is going to be 2x. So x plus 1 squared is not just x squared plus 1 squared. You have these other regions there. So you can apply this to any polynomial, any binomial, anything you're multiplying. Let's say you have x plus 3, x minus 5. You can draw your box, and I'm not drawing this to scale. And let's just start multiplying. X times x is x squared. X times negative 5 is negative 5x. 3 times x is 3x. 3 times negative 5 is negative 15. Now let's write this out. We've got our x squared term. We've got our 3x term. We've got our negative 5x, and we've got our minus 15. Now we can combine these guys, and now it's going to turn into x squared minus 2x minus 15. And we could draw even bigger boxes. Let's say we have x plus 3, and we have x squared plus 5x plus 2. And we could draw more of a rectangle this time. And this is x squared, 5x2, x and 3. And we can just start filling out this box. We got x cubed, we got 5x squared, we've got 2x. We've got 3x squared, we've got 15x, and we've got 6. And we can start combining those guys. Will turn into 17x, that'll turn into 8x, x cubed plus 8x. And that's what we get for our answer. Now, there is actually a better way of doing it once you are comfortable with that intuition. Once you understand what the box method is doing, we can try something different. So what we're going to try is this. Instead of drawing it that way, x squared plus 3x plus 9, what we can do is we can do the same thing with arrows. This x is going to hit this guy. We got x cubed. is going to hit this guy. That's going to give us 3x squared. And it's going to hit this guy. That's going to give us 9x. Now we've used up that x. It's gone bajoom, bajoom, bajoom. It's hit all three things. That x is used up. It's gone. We don't have to use it anymore. There's no other things it can be multiplied by. So now we're going to use this other term, that's 3, and it's going to hit this guy. And that's going to give us a 3x squared. Now you'll notice I'm writing it directly underneath our other x squared term. That's going to give us 9x. And this is going to give us 27. So now we add those terms up. That's going to give us x cubed. 3 and 3 gives us the 6x squared. This gives us the 18x, and this gives us the 27. All right, one more just for fun. You can pause and try this one on your own. Let's do x minus 2, x cubed minus 5x plus 1. Okay, so let's use up that x to the 4th minus 5x squared plus x. Coming underneath, we got negative 2x cubed. Hang on, that doesn't match up, so let's put negative 2x cubed over here. And now we've got negative 10x, that can go there. And we've got negative 2, which I'll squeeze in there. Combining the like terms, x to the 4th doesn't have anyone to combine with. This guy doesn't combine. These guys can combine to be negative 9x. That negative 2x cubed can come there, minus 2, and now you have your polynomial. Okay, that's it.